Let's continue our discussion on logic behind decision tree. By the end of this video, you will be able to explain reduction of variance criterion of splitting a decision node in case of regression problem. In the previous video, we understood how Gini impurity and information gain help to select the best input variable for splitting in a decision tree classifier. As the information gain and Gini impurity are methods for calculating the impurity of the categorical variable, they are not applicable to the decision tree regressor. But why? This is because the target value in a decision tree regressor is a continuous value, and therefore every value present is unique in nature. As a result, we cannot calculate the homogeneity of the subnodes as we did in the case of classification. So what do you think we can do to quantify something similar like homogeneity in a continuous target variable? Perhaps we can split the decision node such that the resultant nodes have values which are very similar in magnitude or are very close to each other. That is, the variation among the values in a node is minimal. But how do we do that? We can do this by measuring the spread of the values in the subnodes. Spread represents variance. And the best way to do that for a continuous variable is to find the variance of the subnodes. We know that higher the variance, farther apart are the values, and lower the variance, closer the values are from each other. And hence, our objective is to reduce the variance. And because of this, the method is called reduction of variance method. As a result, this method is called the reduction of variance. This method uses the standard formula of variance to choose the best split, that is shown on the screen. Here, x is the data point, mu is the mean, and n are the number of samples. Let's look at this node. If we calculate the variance of this node, it will be somewhere around 6. We will discuss how to calculate the variance shortly in this video. Now consider one more node. As all the values in this node are the same, the variance of this node will be 0. So if we compare the variance values here, we can infer that a lower value of variance is leading to more pure nodes, whereas a higher value of variance is leading to more impure nodes. So we can choose the variable with lower variance for splitting. As we have discussed, it is used when we have a continuous target. Now, let's look at the steps to calculate the variance for a split. We first calculate the variance of each child node using the standard formula as shown in the screen. Once we have the variance of each child node, we calculate the variance of split as the weighted average variance of each child node. Let's calculate the variance for these two splits. Please note that variance works with a continuous target variable, and as such it would not be appropriate to apply that in this example, since the target variable is a classification variable. Only for the simplicity, we are continuing with this example by considering plays cricket as 1 and does not play cricket as 0 and treating it as a continuous variable. Let's start with the split on performance in class. First, we will calculate the variance for node above average. Since there are 8 ones and 6 zeros in this node, the mean for this node will be 8 times 1 plus 6 times 0 divided by total observations in this node, which is 14. Now the variance of this node can be calculated using the variance formula, which we saw earlier. On plugging in the values, we get the variance as 0.245. Similarly, we can calculate the variance for the below average node, and the variance comes out to be 0.222. Finally, the variance for the split on performance in class is the weighted sum, which is around 0.238. Similarly, we calculate the variance for the split on grade. We have already calculated these values here, and the variance for the split on class is 0.16. We recommend you to do these calculations on your own and then compare your results with the values shown here. Next step is to compare the variance for both these splits. we got a value of 0.238 for split on performance in class and 0.16 for split on grade. Now, lesser the variance, better the split, and hence the grade will be a better split in this case. And hence, the first split will take place on the basis of grade of the students. So in this topic, we saw different types of decision trees and how the splitting of the nodes takes place in either case. Now in the next topic, we will be looking at the implementation of the decision tree model and see how it works. Just to give you a hint, we are going to make some discoveries about the decision tree during the implementation. See you there.